Hey, this is Dr. B, and let's look at some common chemical formula types. We'll look at molecular formulas, structural formulas, skeletal formulas, and condensed formulas. Molecular formulas simply show the number of each type of atom, usually in alphabetical sequence. If it's an ionic compound, it'll be cation, then anion, for example, sodium chloride. And for this substance, there's really only one way to assemble it, and it looks like that. The reason there's only one way is because carbon typically forms 4 bonds and hydrogen only 1, so if you play around with it, that's all you got. The skeletal formula tries to show this with as little drawing as possible, and they play it, and it looks like this. And the rules are that any bend in the line, like there, or end in the line, is implied to be carbon. And since the honk rules dictate that we have to have 3 hydrogens here if it's a hydrocarbon, we don't draw them at all. So you'd see that you have to figure out that there's 3 hydrogens there, 2 there, and 3 there. And that's the skeletal formula for this substance, which, by the way, is known as propane. If you're typing it out, it's helpful to know how to do a condensed formula, which just kind of writes it out from left to right in order for each group. CH3, CH2, CH3. Let's do the same thing for this molecular formula, which is C2H6O. If you take a look at it and try to draw it using those honk rules, and remember oxygen forms 2 bonds, there's 2 ways you could do it, either like this or like that. So although they share the same number of carbons, hydrogens, and oxygens, they're very different substances. This substance we call dimethyl ether, this one we call ethanol, and they have very different properties. If we try to draw it skeletally, we don't have to draw much. We would draw a line from the oxygen to the carbon. That's all that's needed, and for the other one. So there's the skeletal formula for that dimethyl ether. And for here, we could draw it like that, and you can drop the the H if you want to, but they usually don't, since they want to show you that that alcohol functionality is present. And the condensed formula is pretty straightforward. Just read it left to right, and there it is for dimethyl ether. And there it is for ethanol. Sometimes substances get a little bit more complex. If we draw one particular isomer of this substance, you could draw it this way. And I'm doing this to show you that there is some stereochemistry in this particular substance. If you assemble it, you'll see that these hydrogens and these alcohol functionalities are fixed. They're not free to rotate. So they could be either up or down. That wedge shown there means that it's coming out of the plane of the board towards you. Those hatches there show that it's going into the plane of the board or the laptop or your phone, and meaning away from you, and they're locked in place. We can draw it skeletally. I'd probably include the OHs there to show you we have 2 alcohols, but not much else. Just a triangle will do it. Can you see that there's 1 hydrogen there, 2 hydrogens there, and 1 hydrogen there? Skeletal formulas are a very fast way to draw a structure, and the condensed formula doesn't really apply because if you're going in a circle, it becomes difficult to see where it begins and ends. You can't really type it out that well. Okay, that's a quick look at some chemical formula types.